All right, today we're going to talk about an infinite series. Now, as you may recall, on our last assignment we talked about a finite series, which was a series that only went for so long and then ended. Now we're doing an infinite series, which means that this series is going to go on forever. So here we have an example of an infinite series, and notice the three dots at the end indicate that that series is going to keep going forever. Now, when we try to find the sum of an infinite series, there are two possibilities. That sum could either converge or it could diverge. And our job when we're trying to take the sum, first we need to decide, is it going to converge or diverge? So first we're going to talk about a converging series. And a series will converge if the common ratio r, remember that's the number we're multiplying by each time, if that number is less than 1. So if we have a converging series where the common ratio r is less than 1, then we can use this formula right here to help us find the sum of that series. So the series is often written like this, using that summation notation. And in that formula, f sub n, remember, is going to equal the sum of the series, which is probably what we're going to be trying to find. A sub 1, remember, is this term right here, and that's going to be our first term in the series. And then r, remember, is the common ratio, or in other words, the number you're multiplying by each time. And when we're written in summation notation, that's the number right here that shows up in the parentheses. So here we have an example of a converging series, 1, 1/2, 1/4, 1/8, and it's converging because the common ratio is 1/2. We're multiplying by 1/2 each time, and notice how each subsequent number is smaller than the number was before it. So that's how we know the series is going to converge. Well, if a series isn't going to converge, then it will probably diverge. And a series will diverge if the common ratio r is a number that is greater than 1. Now, if the series is diverging, that means that the sum is going to go to infinity. And that happens because the numbers get bigger as you go along. So here's our example of a diverging series, 1, 2, 4, 8, 16. And that's diverging. Notice how each subsequent number gets bigger as we go along. And it's diverging because our common ratio r is 2. We're multiplying by 2 each time, which is what causes that number to get bigger. So now on this next section, there we go, we have been asked to determine the sum of the series if the sum exists. If it doesn't exist, notice we've been asked to simply write series diverges. So we can determine if the series converges by looking at the common ratio r. So here on example 1, our common ratio r is 1/4. Since 1/4 is a number that's smaller than 1, we know that the series converges, which means we can find the sum. Now if you look back, remember we use this formula, s sub n equals a sub 1 over 1 minus r, to find the sum of the series. So I'm going to just write that formula right here. S sub n equals a sub 1 over 1 minus r. Now we already know that the r is that 1/4. We also know a sub 1 is the first term of the series, which in this case is the 2/3. So my s sub n is going to equal 2/3 over 1 minus my common ratio r, which is 1/4. Well, I know that 1 minus 1/4 is going to give me 0.75. So this becomes 2/3 over 0.75. And I can type that into a calculator to figure that out. I'm going to go ahead and use Google as my calculator. So here's Google, and I want to know 2/3. Notice how I'm going to put that fraction into parentheses. So there's my fraction 2/3 divided by 0.75. Okay, and then if I hit enter, Google tells me that it equals 0.88 repeating. So I'm going to go ahead and round that to 0.89. And that's going to be my sum here on example 1. Now on example 2, notice that our ratio this time is 5/4. Well, 5/4 is actually equal to 1 1/4, which is a number that's bigger than 1. So I know that this particular series is going to diverge, which means it goes to infinity and I can't find the sum. Let's go ahead and look at example 3, where we have 9 plus 6 plus 4, and so on. Now, in order to do this problem, we need to know what our common ratio is, and they didn't tell us what that common ratio is. But I know that I'm going to take 9, multiply it by whatever that common ratio is, and get the next number in the sequence, which is 6. If I simplify this problem, I can divide on both sides by 9, which will give me that r is equal to 6/9, or in other words, 2/3. So since my common ratio is 2/3, I know that this series will converge and I can find the sum. So again, I'm going to use that sum formula, which is a sub 1 over 1 minus r. So my a sub 1 is the first number in this series, which in this case is a 9. So I have 9 over 1 minus my common ratio, which is 2/3. Now I'm going to go ahead and just type that into Google to figure out what it is. So I have 9 divided by, notice that I'm going to put parentheses around my denominator, 1 minus that common ratio, which was 2/3. So when I type that into Google, it tells me that it equals 27. So I know then that my sum here is going to be equaling 27. Last but not least, we have this story problem right here. Emily is driving a stake into the ground. On her first strike with the mallet, she drives the stake 3 inches into the ground. On each subsequent strike, the stake goes 25% of the distance of the previous strike. So this first question we've been asked to answer is to write an infinite geometric series to represent how far Emily can drive the stake into the ground. So since it's an infinite series, I'm going to write my summation. We're going to start with k equals 1 and go up to infinity. Then I know that on the first strike, we went 3 inches into the ground. So my a sub 1 is 3. My common ratio r is the 25% that we go in on each subsequent strike, but I'm going to want to write that as a decimal. So remember, I can bounce that over twice, bounce the decimal over twice to get 0.25 as the decimal to the k minus 1 power. So that's going to be my infinite geometric series. Once I know that, I can evaluate the series to figure out how far Emily can drive the stake into the ground. I'm going to use my infinite formula, which is the s sub n equals a sub 1 over 1 minus r. Now I know that a sub 1 was that 3 because that was the first number in the series, that was the first strike, over 1 minus my r, which is 0.25. I'm going to just go ahead and type that into my calculator. So I have 3, I have 3 divided by, parentheses around the denominator, 1 minus 0.25. And my calculator tells me it's 3.85 if I round that answer. So I get that this is going to equal 3.85 inches that Emily can drive her stake into the ground. So that's how we do the assignment. Go ahead and download the assignment yourself and try it out.